All right, so these are the explanations for the chapter 3 test. Starting off with the very first question on number 1, it's a U substitution question where your U is actually going to equal your B, which is x to the positive 1/3 power. So I'm going to substitute, I'm going to get rid of x to the 2/3 and call it U squared. I'm going to get rid of x to the 1/3 and call it U. And I'm going to leave -6 the same. So when I factor this, I get x, well, let's say U minus 3 times U plus 2 equals 0. And then I get U equals positive 3 and U equals -2. Okay, now U actually equals 1/3. So I'm going to substitute the 1/3 here and here, and I'm going to say x to the 1/3 equals 3, and x to the 1/3 equals -2. And then the way you get rid of a cube, or the way you get rid of a cube root, is you cube both sides. 3 to the 3rd is a positive 27. And if I cube this, and I cube this, x to the 3rd, or -2 to the 3rd is -8. These are your two answers. Some people, when they answered this question, they had both of these answers, but then they crossed off -8 because they thought it was a extraneous solution. If you crossed it off, I still give you credit for it because I was pretty generous and lenient with this question. If you had both of these, or if you had both of these originally and you crossed this off because you thought it was you thought it wouldn't plug back in, it does. But anyways, I gave you credit for that if you had these. All right, the second question was another U substitution question. This one's a little more difficult, I think, where the U is your B, which is root x plus 5. Because if you square x plus 5, you're just root x plus 5, you're just left with x plus 5. That's why it's 4 times x plus 5, because it's 4u squared plus 3u. If I subtract that one, it equals 0. And then I have to set up using a quadratic formula. So I would have x equals -b plus and minus the square root of b squared minus parenthesis 4 times your a, which is 4, times your c, which is -1. All over 2 times your a. All right. Simplifying this, I get -3 plus and minus, this is 9, minus -16, which becomes positive. Give me 25, which is square root of 5, all over 8. I'm going to get two answers. I'm going to get a -5 or -3 plus 5, which is -2 over 8. And I'm going to get -3 and -5, which is -8 over 8, which simplifies to u equals, this is going to give me -1/4, and this is going to give me -1. But remember, coming all the way back here, what does u equal? Boop. Square root of x over 5. Square root of x plus 5 equals 1/4. And boop, square root of x plus 5 equals -1. This will not work because you cannot have the root equal the negative answer. This is the only way, this is the only thing you're doing. So the way you do that is you get rid of the root by squaring both, and you get x plus 5 equals 1/4 squared, which is 16. Subtract 5 on both sides, get a common denominator, and you're going to be left with -79 over 16. Minus that 5, that goes away. There you go. That's number 2. Okay, number 3. So if I set this up, I'm going to have 4x, this is number 3, I'm going to have 4x minus 6 is greater than or equal to 18, and 4x minus 6 is less than or equal to negative 18. Solve this, and you're going to add 6, divide by 4, add 6, divide by 4, and your answer is going to be x is, this is going to give me, if I add 6, it's going to give me 24 divided by 4 is 6. And this is going to give me, if I add 6, I'm going to get negative 12 divided by 3 to get, divide by 4 to get x is smaller than or equal to 3. These are your two answers, which is letter choice C. Okay. Number 4. Graph these two inequalities. This is a pretty easy question. First, if I graph the very first one, negative 1/2 x squared plus 4, I'm going to go up 1, 2, 3, 4. Then I'm going to go down 1/2 over 1, down 1/2 over 1. It's going to be a solid quadratic. I'm going to use a point right here, plug it in. The testing point. 0 is less than or equal to negative 1/2 times 0 squared plus 4. This is a true statement. I shade inside of here. All right, 0 is less than or equal to, this is 0 plus 4, which is a true statement. So I include that feasible region. Second one is y is greater than negative x, which is negative x line is going to look like this. And it's greater than, so it's going to shade up, 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 up. But all I care about is the feasible region, which is right here. That's what the graph looks like for number 4. Okay, number 5. Number 5, the way that you would have shown me the work is doing each one of the questions, but I did this so you wouldn't have to do 4 different questions. I actually gave you for number 5 the answer to be the very first one, because if you solve this, you're going to get x minus 1 is less than 3, or x minus 1 is greater than a negative 3. And then if I add 1 to get x is less than 4, and add 1 to get x is greater than negative 2. So that means it's smaller than 4, less than negative 2. It's in between, which is A. A is the graph that shows that it's in between negative 2 and positive 4. And it's an open circle. That's why it's not equal to. Okay, now for number 6, what we got to do is we're going to have to graph this, consider the quadratic inequality. All right, first I want to move everything to one side of the equal sign. This is for number 6. X squared plus 2x. If I subtract 12, I get negative 15. It's less than or equal to 0. Factor x minus or plus 5. X minus 3 is less than or equal to 0. And I have x solving. X is less than or equal to negative 5. X is less than or equal to negative or positive 3. So my two boundary points are positive are negative 5 and positive 3, but they want you to graph it on a number line as well. So you have to choose choose a coordinate and see which one of these are true and false with it. I would choose 0, plug a 0 back into this, and let's see if this is a true statement. 0 squared plus 2 times 0 minus 15 is greater than 0. So is negative 15 greater than or equal to 0. 0 makes this an incorrect statement. So if any one of these has 0 in it, it is not going to be true. So this one would include 0. So this is actually going the opposite way. This doesn't include 0, so this one's good. So here are my two solutions. It's bigger than 3, and it is smaller than -5 or equal to. That was number 6. All right, number 7. This is a U substitution question for number 7. Number 7, my U is going to equal my B. When I say B, I mean ax squared plus bx. My the term next, not B, but the term next to my B. My U is going to equal x to the 1/3. So I'm going to rewrite it as 28u squared plus 5u minus 3 equals 0. Solve by quadratic solution or quadratic equation. Negative b plus and minus the square root of b squared minus 4 times my a times my c, all divided by 2 times my a. Big numbers, but look, boom, that's what we got a calculator for, so you don't have to worry about any of that. Nothing. All right, so I have 25. This is going to give me, these two negatives are going to give me a plus, so it's going to be 25 plus, and then parentheses, 4 times 28 times negative, or not negative 3, just 3, is going to give me 361. 4 times 8 times 3, 25. Okay, so I have -5 plus and minus the square root of 361 all over 28 times 2 is 56. Okay, I'm going to square root 361. Square root 361 is going to give me 19. -5 plus and minus 19 all over 56 to give me -5 plus 19, which is 14 over 56, and -5 minus 19 is going, -5 minus 19 is going to give me -24 over 56. All right, but remember, I think we can reduce these. So we would have this u is going to be here and here. So it's going to be x to the 1/3 equals 14 over 56. X to the 1/3 equals -24 over 56. And remember, you're going to cube this and cube this. Boom. Cube this and cube this. And this is what I would do, so you don't have to simplify the fraction. I would just do 14 divided by 56 equals, and then raised to the 3rd power. You're going to get 0.015. That's one answer. And let's do this one. 24 divided by 56, and then raised to the 3rd power is going to give me -0.078. Those are your two answers. That is for number 7. All right, for number 8, you have to figure out where these two solutions intersect algebraically. So what I would do is this. I would get the y all by, we could actually, there's a couple different ways for number 8. I think probably the easiest way would be just straight up elimination from math 1. 2x minus y equals 5. 5x plus 2y equals 8. I'm going to multiply this whole row by 2 to get my y's to cancel out. So 2 times 2x is 4x. 2 times -y is -2y equals 10. And then I have 5x plus 2y equals 8. These cancel out. I get 9x equals 18. x equals a positive 2. So if I plug my 2 into either one of these, let's just plug it into this one right here, and I'm going to get y. If I plug it into 5 times 2 is 10, move that over, divide everything by 2, you're going to get negative 1 as an answer. Okay, for number 9. It looks like this, and then you got one coming up like this. The y-intercept right here on this one is 3. This is shaded below because it's shaded right here. So it's less than or equal to, because it's a solid line. It looks like the slope is what is it? Down 3. 1, 2, 3 over 4. Down 3 over 4. Here is your first equation. And then for this dude right here, this is going to be y. This is going to be less than, because it's also shaded below, because the feasible region is right here. The y-intercept right here is what? Negative 2. And it looks like your slope, if you look at the graph, you go up 1, 2 over 1. So up 2 over 1, which is going to be 2x. Here's your 2 right here. Those are your two solutions, or your two linear inequalities that give you this feasible region. Shabam, right there. Okay, the very last one, number 10. We have y is greater than or equal to x plus deuce. I'm going to graph this first. Absolute value, you go 2 to the left right here. And your invisible shape is 1 infinitely, up 1 over 1, up 1 over 1, up 1 over 1, and then the same other way. Up 1 over 1, up 1 over 1, up 1 over 1. Choose a coordinate and see if it works. Let's choose 0, 0. That's the easiest. 0 and 0. So is this a true statement? 0 is bigger than absolute value of 0 plus 2, which is 2. This is not a true statement, so we are not going to include this in our feasible region. And there's the first graph. All right, let's do the second one. Second one's a little longer, but it's still super simple. Y is less than or equal to negative x minus 2 plus 3. My vertex is going to be to the right 2. 1, 2, 3. I'm sorry, to the right 2. 1, 2, and then up 3. 1, 2, 3. Boom, right here. And then you're going to go down 1 over 1. And then down 1 over 1. And then it's going to continue like this. It's a solid because it's equal to. There's this graph. Let's use 0, 0. 0, 0 is it's either inside or outside of it. Let's plug in a 0 and a 0 for here and here and see if this is a true statement. So 0 is less than or equal to. 0 minus 2 is negative 2. Absolute value of negative 2 is positive 2 plus 3, which is 5. This is a true statement, so we are going to include this. And this is our feasible region. So technically, there is no solution. Now, some people actually they just graphed this, and they just graphed this, and they wrote no solution. I didn't give you credit for that because I needed you to show me how you knew that there was no solution, not just writing no solution. Because as far as I know, you could have just got the answer for somebody else and just wrote no solution. I needed to see the feasible region in both of those to understand that there was no overlapping.